Hi, everybody. I just wanted to take a moment. I know I mentioned in today's live lesson I would post a video if I got some questions regarding the second part of the review sheet that I posted today. And I only got a few, I didn't get that many, but I figured I'm going to do this anyways, just to have that extra step-by-step kind of tutorial to go through all of this. So again, what we did today is we took a chemical reaction and we figured out the oxidation states for every element. We figured out what was oxidized and what was reduced, and then we wrote the half reactions. So we're going to do that. This one is a little bit trickier because we have copper and iron in a compound. So copper has multiple choices on the periodic table. Iron has multiple choices, and so do the sulfurs. So we're going to use some tricks, and one of the tricks is using the polyatomic ion sulfate to figure out the charge of that metal, which we did in the video this morning. So the first thing I'm going to do is write down the charges that I know for sure. I know that iron has to be 0 here because it's all by itself and it's neutral. So if it's neutral, that means 0. It's got to be 0. Copper is also going to be 0 on the product side because, again, it's by itself and it's neutral. Oxygen has to be -2. Okay, so I'm going to put my -2s there. Okay, so far so good. So the first compound that I'm going to work on here is the copper sulfate. Now, copper has multiple choices on the periodic table, and sulfur has multiple charges on the periodic table. But what I'm going to do is use the charge of the sulfate. Sulfate is -2. That whole thing, okay, is -2. That's on table E. That's why I mentioned early in the year it's important to know and recognize your polyatomic ions because you can use that information. So since the sulfate is -2 and I have 1 copper here, that copper has to be +2. It has to be. All right, so I got a +2 for the copper, -2 for the sulfate, the whole thing. That cancels out in an ionic compound, so we're good to go with that. But I still have to figure out the sulfur in there, okay? I still don't know what sulfur is. Now I can use that information over here as well because iron has a couple choices too. So again, if I look at the fact that sulfate has a -2 charge according to table E, I know that this iron is going to be +2. But again, we're still trying to figure this out, that's sulfur. All right, so I'm going to break these down into our equations that we've been using to figure out oxidation states. So we always take the charge and the number of atoms in that formula, and we make everything add up to 0. Okay, so my copper has a +2 charge, and I only have 1 of them, so 2 times 1. Sulfur, I don't know the charge, and I have 1 of them. Oxygen has a -2 charge, and I have 4 of them. Now all of that will add up to 0. Okay, so just take a quick look at that. For each one, this is for copper, this is for sulfur, this is for oxygen. And it's charge times number of atoms, charge times number of atoms, charge times number of atoms. So now let's clean this up a little bit. Let's get rid of some of these parentheses. So I have 2 plus x, because it's x times 1. And then I have -2 times 4 for a -8. And that'll equal 0. So I'm going to condense this a little more. I have my x, and then I have 2 and -8. So I'm going to put the 2 and the -8 together, and we're going to get x minus 6 equals 0. I'm going to add 6 to each side. So these will now cancel out. And I get x equals +6. So that means the charge of sulfur is +6. Okay? Now this is going to look very similar for the iron sulfate. In fact, it's going to look absolutely identical because the charge of the metal is exactly the same. The number of the metal atoms is exactly the same. The number of sulfurs is the same. The number of oxygens is the same. So we will literally be plugging in all the same numbers. Okay? So if I had this for copper, this for sulfur, and this for oxygen, if I were to do that again at the bottom here for the iron we said is +2, and I have one of them. The sulfur, we don't know, and we have one of them. The oxygen is -2, and we have 4 of them. So I'm going to do iron, sulfur, oxygen. And again, we're going to condense this. So I have 2 plus x minus 8, all equals 0. All right, again, should look familiar. Condense this a little more. X minus 6 equals 0. Add 6 to each side. And I end up with x equals +6. So the sulfur has a +6 charge as well. Okay, so we're good. First step is done. Oxidation states are all set, ready to go. I am going to erase this because we need to do our half reactions. So if you need to copy down any equations, label anything, pause the video right now, so that way you're able to get that information. So the next step is to find out what is oxidized and what is reduced. So we have to remember that whatever is oxidized gets more positive, okay? And whatever is reduced is going to get more negative. So we look at our charges. A couple things I could see. Well, we just figured out that sulfur is exactly the same, so we're not going to look at sulfur. Oxygen, exactly the same. So what's changing is the iron and the copper. So which one gets more positive? The iron. Iron goes from 0 to +2. Okay? Goes from 0 to +2. The copper goes from +2. Now I'm going to leave a little room here because if you remembered, reduction, we add our electrons to the reactant side. Copper goes from Cu +2 to Cu0, neutral. So that charge drops. So now we have the elements that were oxidized and reduced. We wrote them down with their charges. Okay, whatever their oxidation state is, that is their charge, so we throw that in. And what do they turn into? So Fe turns into +2, copper turns into neutral. The last thing we have to do is put our electrons into the half reactions to show the electrons lost, and I'm going to put that in parentheses, electrons lost and electrons gained. So I got my electrons lost on the product side, electrons gained on the reactant side. Finally, we add our coefficient to the electron to make sure we have the right number of electrons being lost or gained for these charges to make sense. So to go from 0 up to +2, that's going up by 2. Each electron has a -1 charge, so that means 2 electrons were lost in order to go from a neutral iron atom to an iron with a +2 charge. Copper goes from +2 and drops 2 spots to 0, so that means it had to have gained 2 electrons. Okay. Okay. So now going back to the basics, what is redox reaction? It's when electrons are lost and gained by elements within a reaction. So it is a transfer of electrons. Okay, it's just that simple transfer. Iron is going to lose those electrons, but the copper is going to pick them right back up. Okay, so I hope this helps a little bit. So take a look at those reactions. And again, if you have any other questions, please feel free to let me know. And if you need any additional help before the Castle Learning assignment tomorrow, shoot me a message. Okay? Take care, guys.